Welcome back, everyone. I guess I'm just getting distracted by talking while doing this, but I keep forgetting to label my toolpath. So I went back and labeled these new toolpaths: rough, finish the walls. Another great benefit of having these labeled as such is that you have a little comment here. You can see what each toolpath is actually doing just by looking at it. And it's really just a good way to organize your workflow. Another great way to organize your workflow is breaking toolpaths into separate groups. So what I've done here is I've labeled this toolpath group main operations. Now, I want to create another toolpath group. So this is a machine group, and this is a toolpath group. And within that machine group, you can have as many toolpath groups as you'd like. So for these holes now, I'm going to actually separate them. I'll click on my main machine group, and then I'll right click, and I'll go to groups, and I want a new toolpath group. And I'll rename that toolpath group holes. And the reason I'm doing this is just to keep things organized and tidy, and so that way if I handed this program off to another programmer or another machine operator, they would be able to look at this program and they know, okay, it's facing, these are the main cutting ops, and then now we've got a section for the holes. And it's just good if you come back to a program you've worked on a month ago, you know what everything is doing, and it's nice and organized. So for the holes, we've got these holes over here. Now, based on this part model, I don't really know what these holes are. I don't know what size tap holes they're supposed to be. And a lot of times you get a model and you bring it into Mastercam and it won't even have these whole threads cut into the model like this. And most of the time you won't actually have threads modeled like that. You'll just have a hole. So in that case, it's really important to reference your drawing. So we have our drawing here of our part, and you can see this is the stock page. This is a separate page that calls out just the holes, and then a final page which is calling out the pocket dimensions. So we look at the holes, we can see we've got 7 holes that are supposed to be 1032 UNF to be tolerance, tap to a depth of minimum 0.380. So I know now that I have a 1032 tapped hole, and there are 3 steps to tapping a hole. The first step is spot drilling or center drilling, and what that does is it leaves a little dimple, a V shape in the hole entry, and then the drill can come in, and the drill isn't going to wobble or walk. And then finally, after you've drilled your hole, you'll then come in with the tap and tap that hole. So first we want to center drill those holes or spot drill those holes to create that entry motion for the drill. So let's create a drilling operation. Slightly different selection method here. We're aiming for points now. We're not aiming for chains. So if I go down, I could drill a hole on this point. Obviously, I don't want to do that. So I want to find a point, go to a top view, at the center of this hole. Now, because this thread has been modeled into the part, I don't actually have a really good point because I do actually right there, but these are kind of splines, so you might not get the center. A safe way to bet is to choose where you can see at the bottom here is a nice clean circle. So I'll choose that point, or luckily I have found one here, so I can choose that arc. Either way will work. But you definitely want to make sure that you're choosing the center of an arc. So let's go to a top view and make certain that that's actually in the center of that hole. And it is. So we're going to go and just individually select the centers of each arc. Again, luckily we have an arc to reference. A lot of times modeled threads will not have a chamfer like this, so you won't be able to do what I'm doing. And you'll have to select that bottom circle. So we've got all our holes selected. If you wanted to sort these in a different way, say you selected them in a random order, you can change how they're ordered here. You can have a bunch of different options. I like to select them in the order I want them cut in the first place. This is only 7 holes. If you have 30 holes, you might want to do a different selection method. Obviously, I'm not covering that right now. So we've got these holes selected. We'll click OK. We're going into the cut parameters again. Tool, again, we're not going to be using an end mill, so we're going to be using a different type of tool. Let's filter, and we'll find what types we've got. So a chamfer mill, no. Taper mill, no. Spot drill, yes. You can either choose a center drill or a spot drill. I find spot drills are just easier to use, so we don't have any. There we go, spot drill. My issue here is I selected both drills and spot drills. So I'll unselect drills. We'll use a 1/2-inch spot drill. And we will click and type in spot the holes. Cut parameters, just a standard drill. Linking parameters are depth. For this, we'll just manually type in -0.08, and we'll see what that looks like. All right, so let's simulate this and see. I will click the S key again and step through and see how deep that goes. So we can see we're not quite deep enough to match the edge of that. So we'll add a little bit of depth there. Let's try 90.09. Dirty operation, so we'll regenerate. Backplot, and we'll step through it with the S key again. So that's good. It's coming right down to the edge of that hole. You can go a little bit deeper, actually. We'll go to -0.1. And what that's going to do is that's going to leave a little bit of a chamfer on that hole, which means you don't have to deburr it, and it'll look nice and clean. So we'll go ahead and continue. We've got all our holes, and we're good. So the easiest way to move to the next operation is to just copy and paste it. So we'll hold the right mouse key, drag, copy that after, and now we're going to start drilling. So for a 1032 hole that needs to be tapped, you need to find the correct drill. So I have a drill chart right next to me. If you don't have a drill chart and you have to thread a hole, what you're going to do is go on the internet and type in drill chart or tapping chart, and it will show you which drill you need for each sized hole. So with a 1032 hole, I know that my tap drill size is a number 21 drill. So we'll go and filter out only drills, and we will find a number 21 drill. And that is a 159 diameter. So now we're going to drill the holes. And if I was really going to make this part right away, I would be changing these speeds and feeds here to standards that I know, so that I don't have to go back in and edit each toolpath to change those speeds and feeds. They're already there. For cut parameters, I'm going to go ahead and do what's called peck drilling. Peck drill. And my peck, I could leave it at 0.1. I'm going to bring that up just a hair. I'll go to 0.2. And what that's going to do is go down, drill, come out, go down, come out. And that's going to clear the chip away. Linking parameters. So I want to change that depth. And if I go click that button, and then if I click Control T, that turns off the shading, and now I can see how deep my drill needs to go. You can see how deep the thread goes, and the drill needs to extend all the way down here so that there's room for that tap to come in, because this is a blind hole. It's not a through hole. You need to extend that drill well beyond the tap so that the tap doesn't bottom out. So here we'll go ahead and choose that depth right there. And that depth is 0.58. We'll just go ahead and go to 0.6 and click OK. Again, we have to regenerate our toolpath. And so now, if we look and zoom in there, you can see that toolpath is drilling all the way through. And you'll notice if we backplot that and click the S key here, you've got that peck drilling action there. Alright, so we've drilled it. Now we need to come in and tap those holes. So again, we'll copy, drag, okay, now we're going to tap it. So we know those are a 1032 tap. We'll go ahead and choose a 1032 tap. Filter that out. Let's see, tap, right hand. There we go. 1032. And we're going to tap that hole. Now the main difference here is you really need to pay attention when you're drilling and tapping are these cut parameters. So if I run a tap in a peck drilling cycle, well, you're going to break the tap. Taps are not meant to drill. So the way that tapping works, you have a tap cycle and a rigid tapping cycle. And these cycles may not show up on yours exactly. You might only have tap, so you can choose that. With my machine, I'm going to be running a rigid tap cycle and a peck depth of 0. So I don't want to have a peck. I just want that tap to come straight down and straight out. And what the rigid tapping cycle or the tapping cycle does is it synchronizes the spindle speeds, how fast that spindle is spinning, and it synchronizes it with how fast the feed is. So you have this helix here, and the speed and the feed need to match that helix right there. So that's why we call out a special tapping cycle. For our linking parameters, we know that we need to tap. Definitely don't want to tap to a depth of 0.6 because that's going to that's going to run the tap all the way to the bottom of that drilled hole, and that's going to cause it to bottom out, and then you're going to end up with a part with a tap stuck inside of it. So let's go to our depth selection, and we'll click somewhere right about there. And we know from our drawing that we need to go at least 0.38. So somewhere between 0.38 and 0.6 is where we want that tap to be. So let's go ahead and we'll just extend that down about 40 thousandths. So 0.42, and we'll click OK. And we will regenerate that. So now we can see the depth of our tap is right beyond the threads that have been called out and cut into the model, but not so far that it's going to bottom out on this hole. Perfect. So let's run our whole machine group through verify and see what we've got. Great, so we've got our pockets done, our contours cut, and now our drill has drilled and our tap has tapped. So we've got one final step that's not necessarily a requirement, but I like to do it, is chamfering the edges of this part so that you don't cut yourself and you don't have to sit there with a file and deburr this part manually.